Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we're diving into secure baseline and configuration management, foundational cybersecurity practices that help organizations establish consistent, secure, and well-managed systems. While these may seem like behind-the-scenes processes, they are essential for defending against cyber threats, ensuring compliance, and maintaining resilient operations. Whether you are securing physical servers, cloud workloads, endpoints, or virtualized environments, having a secure baseline and a structured configuration management process ensures that systems remain hardened, consistent, and recoverable. Let's begin with an overview of secure baselines. A secure baseline is a documented set of system configuration settings that represents a known, trusted, and approved state. These settings serve as a reference point for securing devices, servers, networks, and applications. Creating a secure baseline involves specifying required system parameters such as operating system settings, network configurations, file permissions, firewall rules, installed software, patch levels, and security controls. These settings should be aligned with organizational policies, regulatory requirements, and industry best practices. For example, a secure baseline for a Windows server might include disabling legacy protocols like SMBv1, enforcing password complexity, ensuring that all unused services are disabled, and configuring audit logging. A secure baseline for a Linux server might include configuring IP tables for network security, disabling root login over SSH, and setting proper file system permissions. Once a baseline is established, it becomes the expected state for that system type. Security teams can compare actual configurations against the baseline to detect unauthorized changes, misconfigurations, or policy violations. Secure baselines play a critical role in reducing vulnerabilities. Misconfigured systems are among the top causes of security breaches. A missing patch, an open port, or an insecure service can expose an organization to malware, unauthorized access, or data leakage. Baselines help eliminate these weaknesses by standardizing configuration expectations. In addition to security benefits, baselines improve reliability. Systems configured consistently are easier to manage, troubleshoot, and maintain. They support compliance reporting by demonstrating alignment with mandated standards. And they accelerate provisioning. New systems can be deployed with predefined, pre-approved settings. Let's now focus on configuration management. Configuration management refers to the discipline of systematically controlling changes to the configuration of systems, applications, and network devices. At its core, configuration management ensures that all assets remain securely and consistently configured throughout their operational lifecycle. This includes documenting settings, tracking changes, auditing configurations, and validating compliance. Without configuration management, environments quickly become inconsistent. One system may be up to date while another still runs outdated software. One firewall may have logging enabled while another does not. These discrepancies introduce operational risk, compliance gaps, and security vulnerability. Effective configuration management starts with defining configuration items. These are the components that require control, such as servers, databases, routers, or application stacks. For each item, baseline settings must be established and documented. Changes to these configurations must go through a defined change management process. This process involves submitting a request, evaluating the impact, obtaining approval, and implementing the change in a controlled manner. After implementation, the change must be validated and logged. Configuration drift, the phenomenon where systems deviate from their expected state over time, can occur when changes are made without documentation or approval. Configuration management prevents drift by detecting deviations and allowing rapid correction. Tools play a central role in this process. Configuration management platforms like Ansible, Puppet, or Microsoft SCCM allow organizations to automate deployment, enforce configuration policies, and maintain system consistency at scale. Let's now walk through how to implement secure configuration practices. First, organizations must clearly document their configuration standards and baseline requirements. These documents should define system types, approved software versions, security settings, and update requirements. They should also specify roles and responsibilities, who manages configurations, who approves changes, and who audits compliance. Automation is key. Manual configuration is error-prone and difficult to scale. Automated tools apply standardized settings across systems, enforce consistency, and validate that systems remain within defined parameters. These tools can also generate reports for compliance and audit purposes. Regular patching and updating ensure that systems remain secure against known vulnerabilities. Patching is an essential part of configuration management. It must be treated as a systematic process with clear timelines, testing procedures, and fallback options. Rigorous change management ensures that changes do not introduce new risks. Before making any modifications to configuration, administrators should evaluate the impact, document the rationale, seek approval, and perform the change in a staged or controlled environment when possible. Comprehensive training helps ensure that IT and security staff understand how to follow configuration standards, use automation tools correctly, and document changes. Training should also cover how to respond to alerts or incidents related to unauthorized configuration changes. For more cyber content and books, please visit cyberblocks.com. You'll find bestseller books, training tools, and resources tailored specifically for cybersecurity professionals. Also, visit baremetalcyber.com for additional Prepcast episodes, tools, and study resources. Now let's examine specific security controls that support baseline and configuration management. First, strict access controls must be in place. Only authorized personnel should be able to modify system configurations. Administrative access should be limited using role-based access control and enforced with multi-factor authentication. Real-time monitoring and alerting are essential. Configuration changes should be logged, and unauthorized or unexpected changes should trigger alerts for investigation. Security information and event management platforms can integrate with configuration management tools to detect anomalies. Security audits and configuration assessments validate that systems conform to defined baselines. These audits can be performed using automated tools that scan for deviation or manually through periodic reviews. Audit results should be documented and used to improve processes. Backup and rollback procedures are another critical control. If a configuration change causes a failure or introduces a vulnerability, administrators must be able to restore the system to a previous known good state. This requires regular backups of configuration files, snapshots of virtual machines, and version-controlled configuration repository. Incident response plans must include configuration scenarios. If a misconfiguration results in a data breach or system outage, the response team must be able to isolate the issue, recover from backup, and investigate the root cause. Documentation from configuration management tools can help reconstruct the change history and identify what went wrong. Let's turn now to continuous improvement in configuration management. This is not a static discipline. Your baseline and configuration practices must evolve with emerging threats, new technologies, and shifting regulatory expectations. Start with regular reviews. Configuration standards should be reviewed at least annually or more frequently if you operate in regulated or high-risk environments. Updates should reflect the latest threat intelligence, industry guidance, and audit findings. Use incident analysis to drive improvement. After a security event, determine whether configuration contributed to the incident. Did an open port go unnoticed? Was a firewall misconfigured? Did a patch fail to apply correctly? If so, refine your policies and tools to prevent recurrence. Security assessments and vulnerability scans also inform continuous improvement. When findings reveal configuration weaknesses, such as weak encryption settings or excessive access permissions, update the relevant baseline and adjust automation rules accordingly. Collaboration is vital. Configuration management involves security, IT operations, compliance, and business stakeholders. These teams must coordinate to ensure that standards align with technical feasibility, regulatory obligations, and operational requirements. Ongoing training supports improvement. Staff must stay current on tools, policies, and best practices. This includes not just IT personnel but also developers, administrators, and auditors. Everyone who touches system configuration must understand their responsibilities. Finally, adaptive strategies ensure resilience. Consider integrating configuration management into your DevOps pipeline, using infrastructure as code to enforce consistent, secure environments. Apply policy as code to evaluate compliance dynamically. Leverage container orchestration platforms with built-in security policies. These proactive approaches keep configuration management scalable, reliable, and secure. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study materials, and personalized certification support. Deepen your understanding of secure baseline and configuration management and will consistently support your journey towards CISSP certification success.